Go on. Cool. 488 Zuma game. Think about Zuma game. Okay. That is such a useless sentence. You just wasted 2 seconds of my time. Problem later. Okay. Anyway, think about a Zuma game. You have a rows of balls on the table, colored red, yellow, blue, green, and white. You also have several balls in your hand. Each time you may choose a ball in your hand and insert it into the row. I don't know what that means. Insert into the row, including the leftmost place and the rightmost place. Then, if there are a group of 3 or more balls in the same color touching, remove these balls. Keep doing this until there are no balls that can be removed. Find the minimal balls you have to insert to remove all the balls in the table. If you cannot remove all the balls, I'll put -1. Okay, so there are multiple rows. And insert it into the row. Okay. Wait, so it's not multiple rows, it's just that the input is phrased weirdly. Okay. So you have the board, and then you have the hand, and you have to do it. Have to do a certain ball, or okay. So I could choose any ball, or okay, yeah. So I could choose a ball at any time. Okay, and I could insert it into the middle. Oh, insert into the row. Okay. Um, mm, Assume the initial row of boards won't have any 3 or more consecutive boards in the same color. I guess that makes sense. There'll be less than 20 boards. And your hand is at most 5. Okay. I think the number one thing that I noticed about this problem is kind of the constraints. If n is 20, like immediately my head jumps to some kind of brute force. And yeah, and your hand is also 5, so it's small. That's what I was going to say. So I was thinking a little bit. And I think one thing that the first thing I'm thinking about is that because you can't, the problem wants you to make it seem like you could add stuff in the middle and move stuff around, but actually, so my question to think about was, does it really matter? And I would want to argue no. Um, I think there are only a couple of cases, especially with the number of balls being 5, then hmm, the number of balls being 5, then there are only a fixed up states that you can do. And everything is, even though there is a feeling of, I won't say randomness, but everything is very deterministic. Sorry if that's hard to decipher. I'm also thinking through a little bit. But what I mean by that is that I think one natural thing to do is kind of like just keep track of a lot, and you can actually do this in terms of like I think you could very reasonably keep track of all board states with some kind of recursion. But I want but the tricky thing with that is that you may run into memory issues, right? Because with because okay, because the how I would think about it is that okay, let's say n is 20 for board size. Then in that case, well, how many subboards are there, right? Well, it's just 2 to the 20, or 2 to the n, where in this case it's 2 to the 20, which is roughly a million, right? And if you actually store the board in the memory, then that's going to lead to, well, 20 times 2 to the 20, which is equal to 20 million, right? Which is like, and that's just to store the board. So, but because now that we took a look at this this way, we can actually store the board with just 2 to the n bits instead, right? Like an array of 2 to the n bits, which means in that case it's just 1 million entry, like an int array or something like that, versus like this is just bytes or number of characters actually, and plus 1 million entry of whatever you're storing, which is plus 1 million int, right? So that's kind of my immediate thought. Um, and then the thing that I would think about, or I was thinking about, is that okay, but the hand size is 5, right? So that's called M. Uh, then if you do like some rough, and this is what I'm talking about by like deterministic a little bit, is that like if you do some like very loose bounds, then you could say like, okay, well, there's 2 to the n states, and then you could use and then the 2 to the m ways you could use the hand in different orders, let's say, right? So then this leads to 2 to the n times 2 to the m, obviously, which is 2 to the 25, or well, 2 to the n plus m, which is 2 to the 25, which is clearly too big, right? Because that's like 32 million. But I would argue that you can only everything is deterministic in that you can only you don't have to keep track of what I would say that, yeah, for this problem you don't have to actually keep track of what you've used in your hand, because like for example in this case, the only way to get rid of G is by using 2 G's, right? And then so uh, the only like I guess 2 scenarios I want to say. I was going to say 3, but maybe even 2. Where okay, let's say you have 2 B's in a row or something like that, and this you have to take account gaps and stuff so that you can use it. But to get rid of them, you always need 1 B from hand, no matter what, and you're never going to use a second B for whatever reason. I mean, you could use that later in your loop, um, and then this B you need 2 B's, right? So in that case, um, your removal of stuff, I want to say, is almost uniquely determines your hand. Maybe that's not true actually. Give me a sec, because in this case, if you have this, you use the Y and then the B combines automatically. Oh, which is actually an example. Um, hmm. No, but you could still do the delta on. Hmm. That's my intuition of kind of fixing the space, and what I'm trying to get at here is that now if we have that, then we could do a brute force, but we have to reduce this state from this to something like 2 to the n, which I feel like I have a good sense of, but maybe I'm wrong. Hmm. And then the other thing we could maybe think about a little bit is that there's only 5 different colors. Excuse me. That I don't know if it matters that much, except for maybe you can use it to bound off some search states. But hmm. We do definitely want to get to a point where we use the same thing. Uh, 2 to the 5 is 32. Is that good enough? No, sorry. I mean, it's definitely not. I don't know what I said. Like, I meant 2 to the 5 is 32. But 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 so I think if you do brute force, then you would have to do these kind of then that's the number of states you have. But 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 because I think the other thing that I have to keep track of is the min. So actually, I think you can actually reduce this to, even though this is still the name, the number of states, you actually don't need to store all of them, because if you use a breadth first search, then the first time you see the states will be the earliest you can see the state of your board state, and then in that way the hand, you're going to pass it along the queue, but you don't need it. You don't need to keep track of the or rather that is implicit, because that's the number, that's the moves that you're going to do anyway. I think one case that I might have to think about a little bit though is something like if I have a case where I have, I don't know, like y b b y, something like some kind of interlocking thing. So then you could, which goes to, what happens when you have four in a row? Three in a more. Okay. But I think I just want to think about like what happens when you get to the same state but you have a different hand, right? Like in this case, if you use the B, then I guess you're left with a B. Let's say you do the middle B, then you're left with BB. And then you could also maybe, well, if you use two Ys, that's too late, too slow. I'm trying to think if that's a possible case, actually, where you have two choices and that gets you to the same state, like some kind of like crossover thing, or it might take three color boards maybe, but like some kind of like circular dependency type thing. Let's play around with that idea first, and then we'll think about it. Cool. All right. Talk for 12 minutes. Just on kind of thinking about this problem. Okay. Okay, let's start with n equal length of board. Okay, q is equal to just, well, I don't know what I was typing, but excuse me. So now we want to put in the board. Yeah, because every move gets. Maybe I'll do an assertion. I'm not super convinced, but yeah, okay. This is just to what you would call it, so that we have less less kind of overhead. So we only use one version of the string, just for memory considerations. Okay. Equals q dot pop right. And then our default is return -1. Otherwise, okay. Now what do we do? The state transitions. So we want to see if the representation is a little weird, but maybe that's fine. Because there are going to be a lot of, yeah, there's going to be a lot of unreachable states. That's what I'm betting on, which maybe, I don't know, but I did keep track of some stuff, so it seems you're gonna. Let's just say moves. Um, okay, let's just go for the array then. What's a cool way to do it? Basically, what do we want to do? For each position, we could cancel it out with either one or two balls that we use from our hand. Okay, let's do that. Also, I guess in this case, the most balls you can use is 5 balls, so maybe the search step is not that long. Yeah, maybe I overemphasized on the max case, which is very scary, but maybe that's actually not that bad now that I think about it. There's still a lot of unreachable states in theory. Okay. Let's reconstruct the hand, the board. I just say X. Gotta stop using X for everything. Okay, let's just say I then. Now, so we're gonna keep track of the last 2 boards. Okay. I guess we reuse instead of declaring it here. Okay. I guess you only need this ball and the last ball, so actually maybe that's not. Maybe I just need. So maybe that's just one variable. Okay, fine. We want a cute way to construct a hand. Yeah, okay. This is just color count. And then I want some mapping of RG. What is it? RYPGW. Okay. Oh, I could just use index of this, right? Okay. Okay, let's create this, which is for I in range M. Wow, I'm inconsistent with my Britishness and non-Britishness. Whoops. Color count. Well, if it's still a variable, so so color count of hand of I of colors. Wait, isn't it like an index function? Is index a string or? Okay. Nope. Okay. Now we have to do something in it. Okay. Alrighty. Alright. Take a quick 5-second break to see if we got this right. Oh. Is it just pop? What am I thinking of? Why did I pop right? Isn't pop right something? Pop left? Maybe I'm thinking of pop left. No, where? That's why. Pop right, pop left. Oh man, we're pretty bad. Okay. All right, cool. So this matches up what we want to see from here. So we could do the math slightly easier. Okay. Oops. Now let's do the fun part, which is let's reconstruct the board. Oops, this is n. S is equal to none. So okay. So at the end, we know that last is equal to board sub I. Because actually we could iterate this. Piece. If actually, I think one tricky thing I have to consider is that actually, with a breadth first search, you assume that you're only doing one board at a time, which is fine. But then here, you're actually technically speaking doing two boards at a time. Okay, so I have to actually maybe use a heap. This is, and I actually am really familiar with this because I actually was doing this for the last contest where I made the same mistake. So on the Leetcode contest, you can watch it on YouTube if you're curious. But I actually did make exact same mistake. So better late than never on the learning, though, right? And now I know that it's a min heap and not a max heap because I spent a lot of time debugging that. It was sad. Okay, now that I'm here, oh yeah, if that means this is a board on the piece. I guess actually I should keep track here. Okay, if we have two boards, let's use them on this color. I use X. I feel like sometimes I reuse the same variable by accident, shadowing or whatever. Okay. Color count equal to 2. Then we push. So this is heap push, I think. What a weird API. Maybe not. Still thankful that someone did it though. Okay. Now we have 2, then we want to, just remove this one thing, but then, So you put a board here, it removes the current number, but or the current position, but then you have to do something to make sure that it collapses in itself, which is okay. I mean, I'll just write a helper function. I think this is I'll just write a helper function so that, because otherwise this is too much craziness. Yeah. Okay. So what's next? Okay, so let's say we use this board, then the current board. The board is equal to the current board minus this position, and you could do some crazy things with and, but I just prefer it this way, like and not, if you will. Okay, maybe that's more what you may call it, like keeping the theme of bit masks. Okay, but then now we want new board to be collapsed. But then now, this is just d plus 1 because it's 1 farther away. New board, and then, oh, I guess I have to fix current head. Do I need current head? Can I keep this? Could encode this, but there's annoying. There's a lot of annoying code to write, I guess. And I'll just do another helper function. Where's the move, let's say X, move 2 of these from the old hand or current hand. Okay. And now we actually have to pay out debt and write out functions. Okay. So now we just do, let's just do a lazy. There's only 20 characters, right? Oops. Done is equal to force, 1, done. I wonder if that's faster, because I don't need the port. Maybe, okay, let's not worry about premature optimization. I just get it kind of working first. Okay, so let's just keep a buffer of 3 items. If and last append colors dot index of port sub I if then first of all see if they're all the same. Oops, this isn't even right syntax, but I missed another thing where I have to keep track of the position. So okay. This is obviously also not right, but that's fine. And now we could remove this, and we break out the loop, and then try again. So done is equal to false, and then now we export is equal to current board. Move the indexes. Oh yeah, I think at this point, if you're still with me and wondering about my take on this problem and how, and on interviews, I mean, I would say, yeah, again, this is probably a little bit too tricky on an interview side, so I wouldn't worry that much about it. But I should maybe say that not while I'm in typo. But in case you're wondering, this far in. But okay. Quick. I guess current point is equal to next point actually, and then break. Otherwise, I guess actually I don't need this here. I don't. Otherwise, oh yeah, then you just pop left. This may be a little expensive actually, to be honest, but guess we'll see. Return current board. So that's a collapsing. We'll have to do some testing on this. And then to get new hand, we move, which is takes the current hand. Oops. This X color and then count. Oops. Okay, I'm just going to do something lazy. If so, this is a valid thing. And let's go to color. Then we do the other number, x plus 1 to m, and then do the same thing. I copy and paste. Don't kill me. Usually I don't do it, but there's a lot of typing in this one, and I don't even know if this is reasonable yet. Then we return current hand. Just need to do it once. Okay. Oof. So right here now we definitely do not take account some stuffs. So let's see if this actually even won first. So let's take a. Okay, well, I mean, I guess it ran, but because it doesn't apply to this case. Let me put this in a file somewhere. Even though it is just the input, but I don't like to copy and paste that much. In theory, this should print. This should do some stuff. Okay. Non-type and int. Did I? When is current hand none? Did I not return on my remove? That's weird. That shouldn't happen though. Let's just return some ridiculous stuff right now. Let's print this out. It does reach some impossible states. That's right. Because we should only remove stuff that we can, right? Did I have a? It's possible that I have a mistake. Well, this color count is just wrong. I guess I never reset it. That's why. Um, is there like a in Python? Is there like a fill thing? Okay. I guess actually I don't need to. I know that this will be. Okay, fine. Oh, hey, iPhone Fan 5, welcome. This is a little bit of a tricky problem you're joining us for, so oops, how did but yeah, hopefully they're fun. And definitely let me know if y'all have questions. Okay, so now I stopped doing the impossible thing at least. Um, Also, I never have any out condition, though. I guess we don't get here in this case anyway, or at least not by the way that we were doing. Yeah, and then now we want to do, so the exit condition is if current board is 0, return D. And we don't check for having seen this already, so let's do that. Oops. Can we do this in a weird way? Well, let's actually keep, yeah, I was going to say that this could be a little tricky, but since you got only 5 of them, and it's limited, we could can only make up to 5 moves anyway, so let's say the key in this case is you go to D plus 1 and new board. So if key in scene, then continue. Well, I think this is actually, no, is that true? I had to think about this a little bit. Oh yeah, no, because I've added the distance, so I guess if this is, yeah, okay, sure. So that distance, you should have not seen it. Because you don't want to, because you definitely do not want to add something in there that later gets a smaller move. But, and also in this case, I made a mistake. This should be D plus 2 because we're putting 2 bars in, not 1 bars in. Okay. It is if 2. So that's the case for if. Okay, so the other case is if x is equal to, okay, if that is not none, and x is equal to last. No, it's want the index of it, but we also want actually the last index. So this is actually probably I, so then we could check this easier. Because then now, so then now the two thingies are the same. Now new board is equal to, so now you need 1 board. Okay, I should check the board first. If Do I have this right? Yeah, okay. And column count exists greater than 1. That means we have at least one board to use. Then I think this is a different thing from the problem myself because when we enter our website, type that thing twice. Then we want to pop off the I and also pop off the last. And collapse it. Now your key is this one, you put. So we haven't seen this yet, then let's go to it. I mean, I just ignored it, X. And this remove, I just kind of roll the follows. Okay, let's just go remove 2 then. I totally lied in what I wanted to do, so. Okay. Now I have to do the remove 1, and this should be much easier. It's just actually, okay, it's easier because I'm going to copy and paste. Okay, let's also let's print some impossibles. Maybe I should do a sigflow type thing. But okay, let's just run the code and then see where it is, where it's at. Ooh. Oh, did I code something else? I might have coded like moves. Okay. Usually I say scene, but I was gonna keep track of the lowest move there, but okay, well, that's a little sad, but doing 4 moves. Can we do it in 2? Maybe I'm not collapsing right. Okay, because this one, yeah. Oh, I didn't consider the the more than 3 case. Okay, am I collapsing? How do I do this here? All right, let me play. Well, let me take a quick look to see if I don't need. Let me see if this would have been right on the collapsing. And we'll see if. I mean, we'll definitely need to take account of case, but we'll see if it would be right otherwise. Whoops. Oh, -1. Huh. Huh, 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 huh. Why is that? Maybe I could print. Alright, for debugging, let's print this in a good way. Where's my debug statement? Okay, here. Okay. There's a lot of typing in this one, but okay. Seems reasonable. Type faster B, yep. So far, so good, maybe. And also covered the right for whatever reason. Probably not a good move. Okay, so we definitely do not do enough to merge those. And that's why. Okay. So my collapse function as well. Hmm. Okay, let's comment this out. That's not how you do it. Is it how you do it? I don't know. Naming is hard, so that, okay. Tell you that I don't do something, right? Well, why not both? I guess it's reasonable so far. This one's the hard one, or harsh one. Okay. It's gonna be way too much pointing, and this is when I sometimes wish I have set up my local computer to do some of this. But why is that? Do I not append? Is that why? I forgot to append. No, it's here. Oh, because I always chop off even though this is not true. I meant to, okay. I actually meant this. Okay. Maybe this is slightly better. It's probably not slightly worse, but it's hard to say it's better. Okay. What is n right? Why is this only putting this once? Oh no, it's putting it every time. Okay. But they should at least have something. Oh, whoops. Okay. It's funny. It's almost no code change, just a lot of indentation change. Which is, I don't know. It's hard when you do it in a. I mean, I blame a little bit on the in-browser stuff. And oh, this is already reaching a lot of code, but not confident about this though. Even though it worked for that case. Oh no, I'm definitely not confident about this because we didn't like this case it as well, which is what brought us to begin with. But at least we fixed that one place of collapse. But yeah, let's fix this. Okay, this is at least greater than 3. Then check that they're all the same. If not, okay, fine. Well, we could keep this invariant. What is a clean way of doing this? I mean, I know I could do it in a number of ways. I'm just trying to figure out what is the clean way to do this. But okay, okay. But maybe there isn't just Um, okay, fine. I have to rewrite some part of this. Maybe that's the clean way. If okay, let's say current color is equal to this thing. If If this is okay, this is 0. We just continue then. We have to do this thing with two. Yeah, with the index as well. Okay. And then else. What? Well, no, that's index is not equal to current color. Okay, and that should always, that should always terminate because you insert, oh wait, no, I don't, so I lied. So that, now it should always terminate because this is to stop, right? Okay. And then now, or we move from the beginning, but we probably want to keep, we don't want this to happen all the time. We only want this to happen when current, such a mess. So we want it to happen, trigger when a different color comes in or at the end, right? Okay, fine. So yeah, is that the right way to do it? Yeah, I think so. Okay, fine. But then in that case, we don't do this yet. And let's take a look. Why is this indentation? Is there something wrong with my indentation? What's this going here? I missed a bracket somewhere. Oh, man, my code is a mess now. But what is that? Why is my auto indenting weird? Okay, fine. Guess we could do this. Maybe. Well, don't know why I copy and paste that. It was not necessary. But now we know, we can assume that this is true. So now done is equal false if. And now we can assume that everything in last has the same color. Okay, so next for I is not good. For index. And just the color, I guess, in last. And then now let's break and then just restart the process so we don't do anything weird with, because you want them to collapse. And I guess in theory there shouldn't be two places where it collapses, but let's just do that first to be safe, unless we're forced to, then that's another story. Yeah. Okay. Otherwise, nothing happens. Nash, last is just go to color is new. Okay. That should be mostly okay, maybe. And then now if I've done this too. What? I want this to be after the for loop. Oops, what did I do? Okay. Now to do this whole thing again. Okay. Should might help us. And that's good. Well, this breaks out the for loop, but then it doesn't query last, so we would try to do it twice. Oh, what a mess of a code. Let's see if this makes it any better. I shouldn't have deleted that other code because I still have my keyboard here. Oh, right. Oh well, this should be 0. Whoops, because we went back to not putting it in. Okay, well, still wrong, but maybe slightly better. Alright, why did I remove all those debugging things? But yeah. Yeah. Definitely a little bit on a quieter stream today, and also, man, an hour in this farm. So definitely on the contest, I would have failed, or at least like I don't think I would have time for this. So yeah, that didn't happen. So that's a little sad. Let me see if the other thing still works. Like almost like just like regression testing at least, since I rewrote a lot of stuff. No, so definitely regression there, but that's fine. You still need this to be right. Do I not a pen? Oh, the else is. But if it's the same, I don't have pen. Okay. Okay, okay, okay. I just want this for now and then. It's not a big deal. I don't know if I should worry about performance. Hopefully not, but oh well. I should worry about wrong answer first, clearly. Do I not do this? I thought I did. Let's. Maybe I have it off by one somewhere. Okay, well, I guess it just never gets to the end. Did I miss the case? So now we have. Oh, man, wow, what a silly mistake. Okay. I feel like that felt weird when I was typing it. I remember having a moment, but then I just forgot about it. Hmm. Okay, but now we have to worry a little bit about performance, which not all the time do I test it, but okay. Let's just try, was it 20? Let's just do this like a lot of times. Now it's 18, 20. Just okay. I mean, oh, whoops. Then let me remove another print. I have definitely failed tests before where the print took too long. So maybe I just didn't do it that way. Let me try again. Where the print eats up I/O and then it takes a lot of space. So definitely recommend not doing that. But wait. Oh, because I have the deboard thing. That's right. Okay. So it took 168. See if that fast makes it faster. Okay, it did not actually. So awkward, but let's see. I mean, I'm not sure that this is the longest case to be honest, but it's long enough. So okay, cool. Wow, I mean, so I didn't need to worry that much about performance apparently. I mean, in terms of speed. Let me catch a breath for a second. I spent an hour on this one, so definitely if this was on a contest, well, I would have been host a little bit. I could have done faster. I mean, there's a lot of typing, 114 lines of code, and maybe I could have. I think one thing maybe I made a little bit premature optimization is what I said earlier. But I think when I was analyzing the states, I was trying to do too much about this encoding and the decoding. Maybe I could have been just. Maybe I could have just kept the string and then put that in the queue. I think um, one thing that I didn't appreciate when I did my analysis on kind of the absolute worst case, and some of this reasoning is because when I was doing this analysis, I was thinking of doing some A star search E thing where things are very kind of not deterministic and kind of just try to figure out the worst case scenario for that. But actually, now that I think about it, you could. I think the one thing that I didn't appreciate was that you can only make 5 moves, which I mean I knew at the time obviously, but I didn't really think about it much. I think if you do 5 moves, then your board stays. Maybe your queue would not be necessarily that filled, and then maybe you could write things much faster that way. Um, I mean, overall, like my solution is still fast enough. Some of that is about memory usage that I was worried about, maybe a little bit excessively. Now that I see them doing better than 100% of people, so definitely people probably implement this queue based thing. But yeah, so the algorithm is still using a heap to kind of figure out the best move, and then just kind of almost kind of like a breadth first search with the queue that way. But I did a lot of optimization on space, but a little bit prematurely. It maybe seems to fan out. Did it tell you the memory usage limit? I guess not. So David spent more time than necessary because a lot of the mistakes were due to that. But I'm also happy that I got it on the first try. So at least either no stupid mistakes or you've seen me catch all the stupid mistakes myself. And also some of that is that the example cases were good enough and representative of the set, which is always a little good, I guess. Um, but yeah, overall, just a search problem. Um, I think the biggest thing that I could have done better is probably the state analysis. 'Cause there are a lot of unreachable states, I think, and the reachable ones are very correlated due to the way the boards collapse. And I think I didn't like. I worry about the worst case that may not happen as much since they're only because if you think about it in a weird way, instead of this being the entire search space, because you only have 5 moves, you can actually there are only 5 factorial times 20 states, maybe. Right? What is that? So 5 factorial is like 120 times 20. So in that case, maybe there are only 3,000 states, and I was doing all this math for no reason. And I think technically on an interview, then like that would come into play. I mean, maybe not necessarily applicable to this state, this problem, uh, but that's something that is worth maybe considering because 5 factorial, basically 5 factorial times 20 is saying, um, no, is that true? Maybe that's not true. Maybe it's 5 factorial times 20 to the fifth. Hmm. But in any case, I think these are things that you could analyze the states a little bit better, and then that will allow you to get a clearer memory usage, which in theory, what I didn't need, but it will allow me to, if we're in a competition, then allow me to kind of type the code way faster and implement it in a more straightforward way instead of all this stuff with bit mask, which is fun, but also a lot riskier and a lot annoying. And like the collapse support function is a lot trickier to write. I mean, even this collapse thing actually could have been like, especially the way I wrote it, could have been like a medium problem, right? So definitely a very tricky problem to get precisely right. But I think in terms of algorithm or conceptually is a very like brute force search problem. So with some optimization around using a heap and stuff like this, but which is, I mean, you could also think about like an A star search where so like you take this and then add another weight as the so then you could differentiate a little bit even more. So that would definitely get you wins. But uh, even then, like I mean, I'm only faster than 50%, but I'm also not that worried because 52 milliseconds, you're way under the times. But yeah, so that's the things I would say about this one. Again, what is my running time? Yeah, it's breadth first search, which depends on the state. But the way I did it was because there are only 5 possible each of these. So the number of states, there are 5 times the number of boards, which is in theory 2 to the 20, though with heavily correlated as we talked about. So a lot of unreachable states. But so that's 5 million times the number of that's the number of states, but the number of operation we do in each is O of n, so times 20. So yeah, so that's kind of the situation we're at. Uh, yeah, and space is correlated to the queue size mostly. So the same goes for that goes to here. Yeah, fun problem. Hope you don't get it on an interview. Hope I don't get it in a competition even. Just the speed type it takes so long, but otherwise.